Hello and welcome. Today we're diving into the exciting world of artificial intelligence. We'll be using some cool techniques and tools to create a question answer system from scratch, such as RAG, that stands for Retrieval Augmented Generation. We'll be also using Knowledge Graph with Neo4J Aura, and we'll be using an interesting new tool called Langflow to create our pipeline. By the end of this video, you have a clear understanding of how to set up the system from scratch they can answer questions for a PDF content. So let's get started. Okay, first things first. I will show you the problem and you will understand why do you need RAG and how it works. So you've probably heard about ChatGPT before, and it can answer pretty much any question you want to know about. But how can ChatGPT handle a question that it doesn't know anything about? For example, how many people came to Tiago's birthday? ChatGPT doesn't know anything about it. So who is Thiago? So it doesn't have this context. So that's the problem that RAG solves. So let me create this query here and see what ChatGPT will answer, and then you can dive into RAG. How we can solve this problem. So how many people came to Thiago's birthday? So ChatGPT answers like, I need more context about who Thiago is and which birthday you're referring to. So that's the specific knowledge ChatGPT doesn't know anything about. So that's the problem that RAG solves. So RAG is a way you can provide context, and then you can ask a question about the context you've provided. So ChatGPT will read the context and will be able to give you the answer. So it's basically that. So next steps, we're going to dive into the RAG and understand how it works behind the scenes. Yeah, now that you understood why you would need to use RAG, let's try to understand how does the conventional RAG work behind the scenes. So you basically have a document, any kind of documents. You can have a PDF or a text document. You can also have multiple documents, and you're going to load these documents. So you're going to use some tool to read these documents, maybe PyPDF or some other tools, and you can also read multiple documents. In this case, I'm using just a single document to make that easy to understand. So let's imagine you have a PDF document here. So it's a good practice to load these documents maybe in a lazy way because in real scenarios you will have a huge documents with multiple pages. You don't want to explode your memory. So it's a good practice to load this document in a lazy way and read that documents page by page. So you also have another concept here that's called chunk size. So you're going to split this document to multiple chunks. Those chunks are parts, pieces of text that belongs to the document. So basically, mean you're going to break it. You're going to split this document into multiple parts. So you want to do that because most of the LLMs that are available currently have context window limitation. That is being used in terms of tokens. Sorry, those tokens are the number of words that are allowed to run during this context window. So that is a good practice to create chunks that are available to fit this context window. It's also good practice to use smaller chunks because you're going to create embeddings, and those embeddings, for some reason, the smaller embeddings are better for in terms of performance to find the data you want, and also good to fit this context window too. So we're going to split your huge document into multiple chunks, and you also have two concepts here. That's the chunk size and the chunk overlap, as I mentioned before. So chunk size basically means that is the size of the length of each chunk you're going to create. So how amount of text is going to be grouped together into this chunk. Chunk overlap means that there will be parts of one chunk into another chunk. That basically is basically a technique to ensure there will be parts of the same chunks in all chunks. So that will make easy to find uh, your documents through similarity score, maybe causing similarity. So, but that can be good or maybe can be bad. So it depends on the scenario you want to use that. Some people prefer to use a chunk overlap of zero instead of adding a number for that. But let's imagine you have a chunk size of 100. That basically mean your length or your style will be 100 in terms of piece of text. But if you have a chunk of a lap of 20, it means that the last 20 words or parts of your text is going to be added to the next chunk. So there will be an overlap from one chunk to another in terms of those texts that are grouped together. But maybe if you do that, you're going to create some problem because parts of the chunks that belongs, for example, to the chunk one will be added to the chunk two as well. So basically, when someone asks a question related just to the chunk two, you don't want to answer that with text that belongs to the chunk one. So that's something that complicated. So you need to pay attention if you really need that and make some experimentation so to see if your system is gonna work better or not using this chunk overlap. Some people prefer to use that as zero. So it depends on you and your project. So after that, you're going to have multiple chunks, and those chunks you're going to use those pieces of the text that belongs to each chunk, and it's going to add them as inputs to this embedding model. So there are a lot of the embedding models available. So you're going to use this piece of text and insert into this embedding model. And this embedding model is going to convert this text into a vector. So that's going to be the embeddings that are going to be used as output for this input text. So this model is going to convert that into vector into numbers that represents this piece of text in terms of numbers. So after that, you're going to use those embeddings, those vectors, and you're going to insert them into a vector database or maybe PG vector or something that can store vectors and allow you to search uh, uh, by using vectors. So we are going to store each piece of embeddings and also the original text as properties of those embeddings. So you can retrieve the original text based on the embeddings. So we're going to insert and use some vector database, maybe VV8, maybe Quadrant, maybe Chroma. So there are a lot of vector databases available currently. And then when the user asks a question, this question is a piece of text, right? And this piece of text is going to be also embedded. So you're going to convert this question into embedded into a vector and transform that into a vector as well. And then this vector that was produced as output that refers to this question is going to be used to find similar vectors they are stored into this vector database. So it basically means that you're going to use using similarity to some measure to find the embeddings that are most similar to the question the user asked. So after that, you're going to find the similar chunks and you're going to return the most similar text as chunk. And remember that for each chunk, you also have the original text. So you're going to get this original text and to insert this piece of text as part of the prompt as context. So we're going to use that to provide to the LLM the context you want to use to ask questions. So we're going to provide that as the context, and also you're going to insert the question. So you're going to create your prompt with the context plus the question the user asked. So then you're going to send this prompt to the LLM, and this LLM will process that and then returns the answer as the output. So you're going to have a piece of text as the answer. So during my first presentation, I asked, for example, how many people came to Tiago's birthday. So the LLM didn't have this context, so that was not able to answer that question. But let's imagine that I have this piece of data stored into a vector database. So this question is going to find the context that are related to Tiago's birthday. It's going to provide that as context plus the question to the LLM, and the LLM will be able to read this context and provide the answer. So it will know exactly how the number of people that were present that came to my birthday party. So that is how RAG works. So the next video I will talk about the most more advanced structure that we can use to improve this RAG system, because this is the conventional way people use RAG nowadays. But there are many techniques we can use to improve this RAG system. One of these techniques is graph knowledge. So there are a lot of techniques that I will be putting focus on graph knowledge, and I will use Neo4J as example, and then change to create this pipeline. So we're gonna run that and integrate that the system to answer questions from scratch. Because, for example, if you use this conventional way of creating RAG, maybe you can have some limitations, because maybe you're not gonna find the answer you want, maybe because the overlap is wrong, maybe because the chunks are limited. So there are some problems here. So they can that you can improve by using some techniques. And one of those techniques is graph knowledge that I will be talking about during the next video. I hope you like this context, and see you in the next video.